Okay, so we're going to talk about solving systems by elimination again. Now, we've already done some systems by elimination where you just add the two equations together and one of the variables kind of goes away, right? So sometimes that doesn't work out. So I made this little flow chart for you to fill in on your notes, and you can kind of follow along, and it'll help you kind of decide where you need to go with this eliminating. So if you can't substitute, um, you'll do elimination. So the first thing you're going to kind of look at the equation, you're going to ask yourself, can I eliminate a variable by adding or subtracting the given equation? So do I already have it so that one of the variables would cancel out? If that's yes, then of course you want to go ahead and just do that. But if it's no, then you're going to ask yourself another question. Can I multiply one of the equations by a number and then add or subtract the equations? So maybe one of them is a 2x and one of them is an x, and if you just multiply it by a -2, then they would, then they would be able to cancel out. So if that's the case, then go ahead and do that. If no, then can you multiply both equations by different numbers and then add or subtract? And this is probably the most difficult one, where nothing just pops out and says this will eliminate itself, but maybe if I multiply both equations, then I'd be able to eliminate. So let's look at what this might look like. So here's a set of equations. So I'm looking at my x's, and I have 2x and 10x. So neither one of those are going to eliminate each other. And then I have 5y and I have 3y. Another one of those are going to eliminate each other. So I'm going to have to multiply by something. Now, again, it doesn't matter if you do x or if you do y. It's just that sometimes one is a little easier than the other. I'm going to do the x's because if I multiplied this by a 5, I'd get my 10. There's nothing here with the 3 and 5 that I could multiply one of them. I'd end up having to do both. And I'm actually going to multiply this by -5. So I would get -10x minus 25y. And then you have to make sure that you multiply the other side as well, because remember, if you do something to one side, you have to do it to the other side. It's already negative, so when I multiply by a -5, I'm going to get 110. Then the second equation, I'm going to keep it exactly the same. I'm not doing anything to that. Okay, and now I can add my equations together. So this right here, of course, that's going to go away, which is what we were hoping for. The next one, the y's, when I do -25y and +3y, I'm going to get -28y. And then 110 plus 22 is 132. Okay, then I'm going to divide both sides by -28. And we get a decimal. My God, let's see if it's a fraction. I got -4.71. Okay, something's not right. That shouldn't be a decimal. Let me back up here. -25 plus 3 is -22. Ah, that looks better. 132. Divide by -22 on both sides. And y equals, what is it, -6? Yeah, -6. Now, that's my y value, and I'm going to come over here and put that in here for y. But I still have to get my x value. So I'm going to have to go back to one of my original equations, and it doesn't matter which one. So 10x plus 3 times -6, 10x minus 18 add 18 to both sides. 10x equals 40. Divide both sides by 10. And x equals 4. And there's my solution, 4, -6. All right, let's try this one. So this one, I'm looking at my two x's. I got -2 and 7. Nothing goes nicely into that one. 15 and 5. Now that one looks pretty good because I can multiply the 5 and get a 15. So I'm going to multiply this by 3. And I'm not going to do negative this time because my signs here are already opposite. If they're already opposite, then I don't need to multiply by negative. So I'm going to write down my first equation. The hardest thing I think about elimination like this is just kind of keeping everything straight. So I'm going to write my first equation down, and then I'm going to multiply through. So 7 times 3 is going to give me a positive 21x, then negative 15y, and then I have to do the 17 times 3, which will give me a 51 on this side. And then I can do my eliminating. Okay, so my x's eliminate. No, it don't. That's a 21, isn't it? Oh, sorry. Negative 2x. This is 21x. All right, 21 minus 2, 19x. The y's eliminate. There we go. Then negative 32 plus 51 is 19. Divide both sides by 19, and x equals 1. I still need to find my y. So negative 2x plus 15y equals negative 32. Negative 2 times 1. Okay. Negative 2 plus 15y equals negative 32. We're going to add 2 to both sides. 15y equals negative 30. Divide by 15, and y equals negative 2. So I can go back up here and, what was that, negative 2? Yeah, negative 2. And put negative 2 in my answer. And so my solution is 1, negative 2. Now, suppose your class sells gift wrap for $4 per package and greeting cards for $10 per package. Your class sells 205 packages in all and receives a total of $1,084. Find the number of packages of gift wrap and the number of packages of greeting cards sold. Let W equal the number of packages of gift wrap, and let C equal the number of packages of greeting cards. So they've already given us our W and our C are our variables, so that was really nice. Now remember, when you're solving a system, I have to have two equations. So I'm going to have to kind of sort out here what numbers go together. And if you remember, we talked about before, the best way to deal with money problems is to have one equation that deals with quantity and one equation that deals with the value. So your class sells 205 packages in all. So that's my total, 205. Now, how many gift wrap packages were sold? Well, W. I don't know. And then if I add that to how many greeting cards, that would be C. That's going to give me that 205. And that's my equation for my quantity. Then I can go back and look at value. I sold a total of 10,084, right? Now I sold the W amount of gift wrap plus C amount of cards, but since this is a money one, we have to deal with that money or that value. So how much are the gift wrapped ones worth? So gift wrap was $4 and the greeting cards were 10. So I'm going to put 4 in front of the W and 10 in front of the C. So if I'm going to solve this by elimination, I'm going to squinch this a little closer together here. Since this is W and C, I can just multiply this whole thing by -4, and that'll let me eliminate my W. So 205 times -4 is going to give me -820. Then -4W and -4C. This equation here is going to stay the same. I'm going to add them together. 264 equals, that eliminates, and then I end up with 6c. Divide by 6, divide by 6, and c is 44. So I ended up with 44 gift wrap packages. And then I can go back up here to this 205. So 205 equals 44 plus C. So 205 minus 44, I know that I sold 161 of those. So again, you want to make sure that you look at the two kinds of problems or two equations, one that has to do with quantity and one that has to do with value. A lot of times this quantity one, it's really hard to figure out because they didn't really tell you anything about the W and the C. They just gave you this total. And you kind of have to infer from that that if I add everything together, I would get my total. So that's how you get that number. All right, let's look at what happens when I can't easily multiply one equation. So in this case, I have a 4 and a 7. I can't multiply 4 by anything to get a 7, and I can't multiply a 7 by anything to get a 4. And then a 2 and a 3. And the same thing there. I can't multiply anything by 2 to get a 3 and anything by a 3 to get a 2. So I'm going to end up having to multiply both equations by something. Now, it doesn't matter if you do x or y, but I notice right here that I have at least my y's are opposite. So I'm going to go with y so that then I don't have to deal with multiplying by negative. So I'm going to multiply this equation by a 3, and I'm going to multiply this equation by a 2. Okay, so again, make sure that you're going to every single term. 12x plus 6y. Multiplying the 14 as well. 14 times 3 is 42. And then down here, I'm going to do the 2. So 14x minus 6y. And then multiplying by the 8 is negative 16. And now I can combine them or add them. 12 plus 14, 26. My y's eliminate. 42 minus 16 is 26. That was handy. Divide them both by 26, and x equals 1. 1. And again, I'm going to go back, just like we did before, to my original equation. I don't really want to go back to these. I just think it's safer if you just go back. Just less messy and less things to mess up on. So put a 1 in here for x. Right, subtract 4 from both sides. 2y equals 10. Divide by 2, and y equals 5. And my solution is 1, 5. All right, here's one for you to do. Why don't you pause the video and see if you can work this one out, and then I'll work it for you. Okay, so now in this one, again, I'm going to have to multiply both because nothing works out nicely where it multiplies to the other. I don't have two opposite signs, so neither one of those stands out to me as better than the other. So I suppose at this point it's just how big of a number do you want? So I could do the 7 and the 3 and get 21. Could do the 15 and the 10. You know, if I did that one, I could just multiply by 3 and 2 to get the 30. I may do that. So I'm going to multiply this one by negative 2. And this one by a positive 3. And I'm doing one positive and one negative because remember, I got to end up with them opposite. So the top one, I'm going to end up with negative 30x minus 6y equals negative 18. Okay, the bottom one, I'm going to end up with 30x plus 21y minus 12. There's my two equations. Now I'm going to add them together. 21 minus 6 is 15. 18 and 12, since they're both negative, we're just going to add them together. So we get negative 30. Divide both sides by 15, and y equals negative 2. Okay, got to go back and find what x is. So 15x plus 3y equals 9. 15x plus 3 times y was negative 2. 15x minus 6 equals 9. Add 6 to both sides. 15x equals 15. Divide by 15. X equals 1. X equals 1. Y equals negative 2. And that is my solution.